let's look at some of the projects that I have created in HTML, CSS, and JavaScript. This is an implementation of the similar to Nature of Code series, one of the popular series on YouTube by Daniel. You can, but he uses P5.js to implement a lot of the code. I love JavaScript, so I'm implementing a lot of things what he has implemented in P5.js in JavaScript. You can look at the random walker that I have implemented using JavaScript. And there is the uniform distribution that I am implementing. You can see the rectangles are uniformly increasing in length over time randomly. And there is the Gaussian distribution that I have implemented. You can see at the edges, uh, they increase very slowly, whereas at the center around the mean, you can see the Gaussian curve. And you can look at a ball bouncing uh, around on the canvas screen. It's basically, you can see also I created one of these things that always follows the mouse, and there is acceleration towards the mouse. You can see a lot of these objects are accelerating towards the mouse. Then there is the wind force. You can look by clicking on the mouse. I'm applying a wind force on the ball to the right. And there is the gravitational force. This mass has a lot of gravity, so you can see all the other objects are attracted to them. So we are implementing some of the physics engine kind of ideas into this code right now. And you can see gravitational force here, and there is the drag force on different balls. You can see you can reset the animation by clicking on it again. You can see a trace of the gravitation. It produced cool animation, so I just created that. You can see there are two stars in this case, and the planets are trying kind of getting attracted to both of them, I guess. But like, yeah, you can see there is a bit of random motion as well. And there is the rotation. The planets are rotating at the same time. They are revolving around the Mars. You can see a bit more realistic. I did not leave them create circles because it's hard to see rotation on circles. So I left some squares. You can see the rotation on them while they are being attracted to the star. You can see a pendulum that is moving around. There is this, you can enter the number of pendulums you want to see oscillating. You can see them uh, right now. You can enter 10 maybe and see 10 pendulums oscillating and at different frequencies along different axes as well. You can see this is a sine wave that I created using pendulums. You can try decreasing some or changing some of these values. You can see I decrease the size of the circle to see the sine wave, and this is the frequency of the sine wave. You can increase the frequency, decrease the frequency, decrease the amplitude if you want to, and you can increase the frequency as well, I guess. And like you can change the positioning, number of points. Maybe you can decrease the points, increase the points so that you can see a more clearer sine wave. You can see the steering behavior. All these agents are trying to steer towards the mouse. These are also agents, but I just created some arrow triangles instead of circular agents. And there is the flow field. You can see an agent walking about the flow field. And I'm highlighting the arrow which the agent is trying to follow. You can see with the red mark arrow that the agent is trying to follow. And it's following this randomized flow field that is slightly randomized towards the right. And I think we already saw that. You saw this as well, I guess. Yes. Yeah, here I am, like you can click and drag and drop some more agents to see multiple agents and a group behavior among them according to the flow field. Mm. And there is Perlin noise. Actually, this I I I implemented a flow field using a library called Simplex Noise. You can see this Simplex Noise library is what I'm using to implement Perlin noise in the background. You can see the agent is following the flow field of Perlin noise. Basically, you can create multiple agents by dragging and dropping them, and you can see a kind of pa a migratory behavior among these agents. You can, I would say, and I'm running this on Vite because I installed some libraries and I wanted to make it easier for myself. And we saw the Perlin noise field right now. I think the dot product, you can see this shows the angle between the main arrow, the line parallel to x-axis and the mouse using dot product. You can see I'm using dot product to project the mouse positioning according to this line. And I'm projecting the all the agents onto this line using dot product as well, some vector math that I was trying to learn. You can see this agent is trying to, this is the future that the agent is trying to follow, and this is the path it's trying to take, this 3-line path, and it's trying to make sure that it is not veering off the path. You can see I can drop multiple agents, and you can see that the red color is what it is trying to achieve. And you can see every time I refresh, the paths changes slightly. You can see this agent is trying to follow the red point, and it's the green point is its expected future. And we can drag and drop multiple agents to see a behavior that all of them are trying to follow the path that we have created. This is migratory behavior of different agents that I have created. You can see whenever I'm clicking and dropping agents, you can see every agent is trying to get attracted to things that are in 25 pixel radius. So now you can see there is this clumping behavior where they're trying to align their speed and direction according to their nearest neighbors of 25 pixels. You can see eventually all of them clump together, even though they start at different starting points. These are agents that are trying to align, but they're trying to not bump into each other. That's why you see this behavior of, you can see this agent is trying to constantly align, but it is also trying to move far away from others so that it does not bump into each other. It's one of the kinds of behaviors that we see in nature. And there is this seeking behavior towards the mouse. You can see all the agents are trying to seek the mouse, but they are also trying to make sure that they are not bumping it into each other. So you have this beautiful pattern that emerges from it. Yeah, I guess these are some of the HTML, CSS, JavaScript projects that I created in by, by looking at the nature of code series.